Hello friends, welcome back. Guys, in this video we'll talk about string constant pull, which is one of the very important Java interview question. So guys, in this video I'll explain what exactly string constant pull is, and I'll also explain how exactly it works and what is the advantage of having string constant pull in Java. Alright guys, so that being said, let's begin the video. Alright guys, so first of all let's have a look how can we create a string object in Java, like what are the different ways to create a string object in Java. Okay, so guys, very first way is by using string literals. What exactly literal? It is just a sequence of characters. Okay, sequence of characters. Second way is to create a string object by using a new keyword. Okay, by using new keyword. Alright, let's talk about string literals, right? So say for example, if I do like this, string as equals to what, I can print, say, okay Java, right? So what exactly this thing is, string as is a string type object having value okay Java, correct? And if I talk about the new keyword, what I can do is string s1 equals to new string, and then I'll pass the string. Say for example, here also I'll pass okay Java. Simple. So basically there are two ways to create a string object in Java. One is by using string literals, second one is by using new keyword. Okay, string s1 equals to new, and then you pass the string. Let's talk about the memory, like how exactly these things, string as and the literal okay Java, is getting stored in the memory. Okay, let me draw a big box here. So for example, this is the JVM memory. Okay, let me just call it what, JVM memory. And inside this JVM memory, what do I have? We have got something called stack. Okay, what else do we have? We have got this another remaining area is what, it's called heap. I hope you guys know about it, right? Okay, inside heap there is one specific area, and this particular area is known as string constant pull. String constant pull, SC. Alright guys, very simple thing. This is the JVM memory. Inside memory we have got a stack, and then we have got heap. Inside heap there is one specific particular area which is known as string constant pull. Okay, let's say I'm using a string object by using string constant pull. String as equals to, let's call it okay Java. Alright guys, so what is s? S is reference variable which is pointing to a string object or a value or a literal called okay Java, right? So now guys, as we know that all the string reference variable goes to stack. Okay, so what I will do, I'll just, let's go here. So s will be stored in stack. Okay, and what about the literal okay Java? So this particular literal okay Java will be stored in the very specific memory which is called string constant pull. Okay, so I hope this much is clear. Like all the reference variable will go to stack, will be stored in stack, and string literals will be stored in string constant pull. Okay, now guys, say for example I have another string. Let me call it string. I'll call it h equals to hello. Okay, now guys, can you explain where exactly h will be stored and the literal will be stored? Very simple, right? So h will go in the stack memory. This will be stored here, and literal will be stored in string constant pull. Simple, so easy, cool, right? Now guys, say for example I have one more string. I'll just create here one more string. So guys, I have quickly added two more strings, s1 and s2 string object. We know that s1 and s2 will be stored in stack, and the literal will be stored in string constant pull, right? So I've got okay Java and okay Java. Now guys, there's a problem. As you can see that we are repeating the same literal again and again. So it means that a string constant pull is not memory efficient, right? So to make it memory efficient, what JVM does is like, so for example, if I'm using a string as equals to okay Java, and this is my very first entry that I'm creating a string object having value okay Java very first time. So what JVM will do, it will simply go and will create this very first entry in string constant pull, right? Because at the very first time nothing was there in the string constant pull, right? So JVM will go and will create okay Java in string constant pull, and then for the next object string h equals to hello, we know that hello is not there in string constant pull, so obviously it will just go and put hello in string constant pull. Okay, so hello will be stored in scp. All right guys, now for the next object string s1 equals to okay Java, so what JVM does, it will simply go and will check whether we have okay Java already in string constant pull or not. If it is there, what it does, it will simply return the reference of that particular memory instance. For example, so what, this s1 will point to same memory location. Okay, And same goes with string s2. We already have OK Java, so s2 also will point to the same memory location, same literal that we created very first time while creating the object s. Okay, so in JVM you won't have these two entries. It won't be there. It won't be there. I hope you guys are getting it right. So what JVM does, it will first go and check whether we have the literal already in string constant pool or not. If it is not there, then it will simply go and create that literal in string constant pool. If it is there, it will simply return that memory reference. Okay, so that particular string reference or object will point to the same literal which is stored in the memory. Okay, I will prove this thing in a minute. Okay, in the demo section we will see. So for example, guys, one more time, I'll just take one more example just to make it very much clear. So if I use string, say s3 equals to, and I call it welcome. Now guys, what will happen? S3 obviously in stack because this is the reference variable. What about the literal welcome? Now JVM will go and check whether we have welcome in a string constant pool. Obviously is not there, right? So what it will do, because welcome does not exist, JVM will create a new entry in string constant pool. Now for the next time, if I have another string 4, right, like this, string s4 equals to welcome, right? Now guys, I hope you know what will happen this time, because s4 obviously it will go in stack. I don't have enough space here, so I'll just put here s4 will go here in stack s4. Now because welcome is already there in the string constant pool, so JVM obviously won't create a new entry. It will make sure that s4 points to the same memory, same string literal. I hope you guys are getting it. Let me give you a demo and then I will make you understand then what exactly string constant pool and how can we make sure that JVM is not creating these literals again and again in the string constant pool. Okay, so guys, let me go to the IDE. I'll just create a class. Let's call it, what should I call it? I'll just call it test only. Okay, so for example guys, very first string was string s equals to what? It was OK Java. Let me just make the font size big so that you can see clearly. Okay guys, so we know about this one, that s1 will go in stack and OK Java will be stored in string constant pool, because at the very first time OK Java is not there, right? So s1 will be stored here in OK Java, because this is the first time we are creating the object, the literal OK Java, right? This is the very first entry, first time we are creating, right? So it will go into the string constant pool. Okay, cool. Now what is happening next? Next is another literal, another string object which is pointing to hello. Okay, so this is the next object, string h equals to, it is pointing to hello. Now guys, what exactly will happen here? Obviously h, the reference variable, will be stored in stack, which is here, and hello. So JVM will go and check whether we have hello in SCP, whether we have hello in string constant pool. So obviously we don't have hello because this is the very first entry which we have here. So now JVM will go and will create this entry hello, okay, because it wasn't there. Cool. Then next time, if I have next object string s1 equals to pointing to OK Java. Now guys, what will happen here? Obviously s1, the reference variable, will be stored in a stack, which is right. What about the literal OK Java? Now JVM, right, it will just go and check whether we have OK Java already in a string constant pool. Obviously it is already there, so there will not be a new entry in a string constant pool. So basically s and s1 will be pointing to the same string literal which is in string constant pool. Alright guys, let's make sure that s1 and s1 is pointing to the same memory location. Guys, what about the double colon operator in string? What it does? It checks for the memory reference, correct? If two objects are pointing to the same memory location, then double equals to operator will give you true, as it will give false. Okay, so what I want to do? I want to make sure that s and s1 is pointing to the same memory location or not, right? So I'll just write here what? Memory reference. Okay, enough for now. And just in case if it is not true, this out false. Alright guys, let me just run and see the output. Guys, what do you see? True, s and s1 is pointing to the same memory location. Okay, same memory reference. Now guys, if I have to test s equals to h, what will happen? Just go and run. It is false. Why? Because double equals to operator, it doesn't compare the values, it compares the memory location. If both of the references or both of the objects are pointing to same memory location, then it will return true, as it will give false, which is true in this case, because s is pointing to OK Java, a different memory location, h is pointing to hello, which is a different memory location. Okay, now guys, let's go back to our example. For example, if I have s2, okay, let's go back here and let's create s2. Now guys, Let's see what will happen if I compare S1 and S2. So I will just put here S1 and S2. What my understanding is, like, as per this particular diagram, S1 and S2 both are pointing to the same memory location. Okay, same object. So basically it should return true. So I'll just put here S1 and then S2. Okay, let's run the program. Java application, what do you see? True. S1 and S2 is pointing to same memory reference. Alright guys, I hope you guys are getting it now. And guys, if I talk about the S3 and S4, what I will do, I'll simply go and create two more objects. S3 equals to, say, welcome. We are creating welcome for the first time, right? For the first time here. So obviously JVM will go and will add this entry welcome in string constant pull. But next time string S4 equals to welcome, what will happen? Literal is welcome. It will just go and check whether we have welcome in string constant pool. If it is there, it will make sure that S4 points to the same memory location. Okay. Now guys, if I have to compare S3 and S4, let's see the result. What do you see? True, right? We know the reason, because S3 and S4 pointing to the same string literal, which is welcome. Now if I have to cross verify, for example, let's compare S2 with S4. Obviously, because S2 is pointing to what? S2 is pointing to OK Java, S4 is pointing to welcome, which is two different memory locations, right? So it will return false. Okay guys, so I hope you are getting it, right? The idea behind string constant pull is to make it more memory efficient. Now guys, so far we have discussed how can we create a string object by using string literal, and what is the purpose of string constant pull. Now guys, if I create an object, right, if I create an object by using new keyword, right, then let's see how exactly the system behaves, what exactly happens behind the scene. Okay, so memory is as is. We have got JVM, we have got stack, we have got heap, and we have got string constant pull. Okay, now let's go and create a new string object by using new keyword, right? String in double quotes, I'll pass the value, let's call it. All right, now guys, you know that a1, because this is the reference variable, will be stored in stack, there is no doubt at all. Second is value. Okay, so guys, one thing, whenever we use new keyword, right, the value will be stored in heap. At the same time, the value will be copied in string constant pull as well. But yeah, here again, JVM will make sure whether do we already have that value in string constant pull. I hope you guys are getting it right. Say for example, let me just go and create one more object here, and this time we'll call it, say, A2. Okay, equals to, so new keyword, and this time also, okay, let's go with welcome, just for example's sake. Okay, a different value. So A2 reference variable will be stored in stack. New, because we are using new keyword to create a new string called welcome, so it will be stored in heap. And because there is nothing in string constant pull, same value will be copied to string constant pull as well. All right, now guys, how can we make sure that it is happening, right? So what I will do, I'll just go and create one more object. Let's call it string s3 equals to new string, and this time also here I'll pass, say, same object. Okay Java. Now what will happen? S3, the reference variable, will be stored in, sorry, let's call it A3. I want to call it A3. Okay, it will be stored in stack. Value, okay Java, will be stored in heap. Okay, so guys, this is pointing to the new memory location in heap. Okay, it is not replacing, but yeah, because at the same time JVM creates the same value in a string constant pull, but this time we already have okay Java, so it won't create a new entry in a string constant pull. So in heap we have got two okay Java, but in string constant pull there will be one entry only. Like now guys, if I go and repeat same, like, let me just copy and paste this one here if I can. So let me just call it A4. Now guys, what will happen? Because A4 is a new object, new reference variable, obviously it will go to stack. And welcome, because we are using new keyword, right? So the value will be created in, again it will go and check, okay, let me store this value in string constant pull as well, but because we already have welcome in string constant pull, it won't create a new entry. Okay, how can we prove this? So what I will do, let's go back to the IDE and I'll just remove everything from here. Let's go and create a string. Okay Java. Okay, sorry, it is A1, right? A1, and I'll just go and create A2 equals to Java. Now guys, if I run A1 equals to A2, what will happen? Because A1 is also having same string object, okay Java, A2 is also having same string object, OK Java. So what is the expected output here? So I'll just call it true here and else false. Let me run the program. What do you see? False. A1 and A2 is not pointing to, sorry, A1 and A3. Okay, so just to match with this example, I'll just change the reference variable to A1 and A3. Okay, because here A1 and A3 both are having same object value. Okay, Java. But in heap, that value is stored in two different locations. Okay, you can see here, right? Let me just take this one. So A1 is pointing to this OK Java, which is in, say, for example, one memory location. It won't be one, it will be some xxx1, and A3 is pointing to this particular OK Java, which is in, say, memory position, let's say 3 only. Okay, so the result is obviously false. Let me run it one more time. False. If A1 dot equals A3 true, sys out false. Okay, so what will happen? This is, I'm using what, A1 dot equals and double equals to. Let me just run this one. So if you see, double equals to is returning what, false, because A1 and A3 is not pointing to same memory location, but yes, the content, the value is same. That's why equals to is giving what, true. Cool, right? Now guys, as I mentioned here, so if you go to string constant pool, I already have OK Java and welcome, right? So A1 is pointing to same OK Java, like this is how this would look like, same value. Even this is also pointing to same. Welcome is here, and as far as pointing this welcome, and this is here. Okay, so let me prove this one. So for example, I want to create a new, what should I call it, s1 this time equals to OK Java. Now we know how this s1 will work, because reference variable, obviously it will go and stored in stack, and later it will be stored in a string constant pool, right? So let's go here. So what will happen, let's go, s1 would be in stack, and OK Java, the letter will be stored in a string constant pool. But guys, remember, we already have OK Java in place, right? So it won't create a new entry. What it will do, it will just make sure that S1 is also pointing to the same OK Java, same memory reference. Okay, how can I prove? So okay, so S1 is pointing to a memory location which is a string constant pool, and A1 is pointing to a memory location which is in heap, right? So obviously I'm expecting false here. I'll just remove this part for now. Control S and run this particular program. What it says? False. And we know the reason. Okay. I hope you guys are getting it right. Alright guys, let's discuss this particular thing again. String A1 equals to new string and then OK Java. S1, the reference variable, will go in stack. OK Java, the value will be stored in heap. At the same time, if this is the very first time, obviously JVM will create a copy in string constant pool. Now guys, my intent is I want to access this particular value which is there in a string constant pool. How can I access this particular? So guys, let's go and create a new object s3 equals to a1 dot. I'm going to call a function called intern. Okay, so let's see how this a1 dot intern behaves. So guys, s3, obviously it is a reference variable that will be created in stack. Okay, now a1 dot intern, right? So what exactly is a1 dot intern stands for? It means that it will call the internal value which is there in a string constant pool. So this s3 will be pointing to the memory which is here, basically an internal value which is there in string constant pool, right? So s3 will point to the OK Java which is created while creating the a1 object. Okay, so let me prove this one. For example, now I know that s3 is also pointing to what, is pointing to OK Java which is in string constant pool, right? Which is in a string constant pool. Now I know s2 and s2 also there in a string constant pool. So for example, if I run, let's compare these values, s1 equals to s3, and let's see what comes out of this one. It says true. What will happen if I compare a1 with s3? Now guys, a1, if you go back, is pointing to OK Java which is there in heap, and s3 is pointing to OK Java which is there in string constant pool, right? So obviously the result will be false. Let's see the output. It says false. I hope you guys are getting it. Alright guys, we are done with this video. Thank you for watching, and please do subscribe my channel.